how they would answer this question here. So that's number 2. Number 3 is asking, what is range in math? So this is a very vague question here, but it's asking, what is range in math? And here, I'm going to read off the solution for you, just to kind of anchor ourselves in something here. So it says here, in mathematics, the range particularly comes under functions, which is correct, where the function is showing the relation between the sets. To know about the range, first we need to know the domain and codomain of functions. In simple terms, the domain is showing the input values, the codomain is showing the possible output values, and the range is showing the actual output values. So the range in mathematics shows the actual output values, which come from the domain of the function. So this here is true, but it's kind of wordy. So let me just draw a function for you. Let me look at this function here, and I'm going to take this function here. So I'm going to assume here this is y equals x squared, and I have here it's not perfectly at 0, 0, but it's okay. I'm going to assume that this is the vertex here is 0, 0. But so what is range in math? When we're talking about range in math here, we're talking basically about the output values, right? So we're talking about where does my function exist in terms of the y value. So function exists in the, I'll say y domain, or no, I won't use the word domain, or in the y axis here. Or where does my function exist, right? As you can see here, I'll do some blue. My function exists only in terms of the y, only in terms when it's above 0 here, right? Because I have all my function, my function exists here and here as well. But as you can see, my function does not exist in this in this region as well, right? The vertex of my parabola here is already 0, 0. So therefore, my function does not exist when it's below 0. So therefore, if I were to write my range of this function, if I were to write the range of my function, I can say that here y, or I can say the range here for r semicolon is, and I use kind of these squiggly brackets here. I can say it's y is a set, belongs to a set of real numbers. And I can also say that y here has to be greater or equal to 0, right? Y has to be greater or equal to 0. Because my function, my y here, can exist at 0. The vertex of my parabola here is 0, 0, right? So it does exist. It has a defined value at 0. But it only has defined values as if it was greater than 0. I wouldn't have... my function does not exist below 0 in terms of the y-axis. And as you can see, you can prove that with algebra, right? I can't, every time I square a number, it will not give me a negative number, right? Again, if I square a positive number, it gives me a positive number. If I squared a negative number, it will give me a negative number or a positive number as well. So therefore, my function, that's kind of the definition of range in math. So this here's the solution is correct. I wish they kind of had a function to kind of graphically show you kind of what is range in math, but this comes back to the topic of domain and range and what exists in terms of the function in itself. So I'm going to say here solution is correct. Let's say good analysis here. It was a little bit wordy, but it's okay. We'll give it to them. It's more so just talking about the function that existing in terms of the y-axis and how we can actually use interval notation to write down specific values in which the function lies on in terms of the range of the function here. Obviously, this is the y-axis. If you want to talk about the x-axis here, it would be the domain. So in terms of this domain here, the domain of this function is x is all real numbers, right? If I go in terms of the positive infinity on the right hand side here and negative infinity on this side here, my function will always exist, right? Even if I put negative 100 squared here, I'm going to get a negative 100 squared, right? I will get a y value here. So if I were to talk about my domain here, in terms of my domain, there's no restrictions in my domain, right? X belongs to a set of real numbers here, and there's no restrictions on that. So I'm going to say solution here is correct. Great analysis for this question. So good solution here is correct.